Hello guys, so today we're going to be learning about promises concurrency method. So suppose you have a dashboard or any page that you have and you're consuming different APIs or different endpoints. Suppose you go and you get some stock options information to show, weather information to show, some quotes, arbitrary or custom random quotes to show, or jokes. And then would you like to put everything in the same page? So you will be making asynchronous work going, taking the resource you want, and then showing it on the page. So what we're going to be showing today is how you can combine them to make the best option and the best resource consumption in your web browser with promises concurrency. Because before that one, suppose with the callback pattern or with the old school, you have to make a call when the callback resolved. It was what it was called the callback hell. So it was like a tilt Christmas tree, like a pine, something like that. Because you have a callback, and when you get it, another, and when you get it, and what is worse, it was in series. So you call, suppose you take 1 second to make one call. When it comes back, you make the second. It took 2 seconds. So you are adding up that time. So suppose you have 1, 2, and 3 seconds. You will see in the examples, you will be a total of 6 seconds to get all the information. When with promise concurrency static methods, you can go ahead and do it in parallel, and you will see how awesome they are and how performant they are. So as usual, I will be creating this new repo, which is called promise concurrency with examples, and we're going to learn all promise concurrency static methods with examples. So in order to do so, what I want to show you is first, as usual, we're going to go to MDN. It's our official documentation, and it is the official documentation for me for every JavaScript related topic. And you will see that it's really long. You can see the scroll on the right is really long, but in a nutshell, more or less, a promises you have a pending when it starts, when it's fired up, and then it can go to fulfill or being rejected. Both, either if the promise has been fulfilled or rejected, that stage is called settle. So a promise can be settled no matter if it was fulfilled or rejected. Settle is another stage, another status of the promise. And then from there, you can go ahead and get the results, because though all this continues is because you can chain promises, as you will see in the documentation as well. But important, it will always be pending as soon as it starts. Then it can go either fulfill or rejected. Those are all the things. And have this specific picture in mind. Let me think if we can make it bigger. So as soon as it starts, it's pending. It can go, if everything goes well, it will be fulfilled. If something goes wrong, it will be rejected. But no matter which one of these two patterns, of the two paths it takes, is going to be settled, that promise. With that in mind, now we can scroll down and over about chaining, about the chainables and many things. And this is the topic that we're going to be covering today, promise concurrency. So we have 4 static methods. What is good about the static method, you know that you don't need to instantiate or to have an object, an instance of the class to invoke it. You can put whatever you are, promise dot all, and you can invoke it, promise dot all settle, any arrays, and you can invoke it. That is why they are static method. You don't need to instantiate the class to make a call or make use of them. So let's go ahead, create a repo first with a README, because later on I'm going to put the documentation and everything there. So once we have it, okay, just with an empty thing. Now here, let me see if we can go ahead and say, okay, we're going to clone a new repo, and it's going to be called promise concurrency with examples. This one. And go to server code. Yes, go there, clone it. It's really fast because it's empty. And now on the terminal, let me go to cd server coder, and now cd promise concurrency with examples. If you do, you can see it's totally empty, just the README. So let me do as usual, make an make it bigger, and then npm init minus y, just to go with the no prompt at all, just with the basic information. Boom, there we have it. We're going to touch index.js, which is the file we're going to be using. I think is everything we need. Let's open VS Code. And now on VS Code, I'm going to make it quite big because we are not going to be using anything apart from index. Then before going that one, let me remove the test because we're not going to test this one. We'll have just start script with as simple as node space index.js. It's going to be firing up what we're going to write in our index.js file. Now with this, with command B, we can get the entire full screen and make it bigger enough so you have good room and space for the code. Let's start. So we're going to do const promise one. You know that you have a new promise. They always have the same signature. You have the result, another pair of parentheses, the result, and reject. And then something will happen here, and then we will check. You can imagine we're going to have promise one, promise two, and promise three, just to make it really simple and easy to catch. Now, here, just to give that idea of an asynchronous work, because otherwise we will have to go and start using public API, the Star Wars API, I don't know, the fake store API, JSON placeholder, just to make use of real endpoints, consume them, and make a fetch call. But we're going to make it with like mockup data, and then we can go in another video, maybe we can go with real one just to see more asynchronous operation in place. But we can mimic that with the say timeout. And we're going to say init a callback that is going to happen something after a certain delay. So for the first one, it's going to be the fastest one. So it's going to take just 1 second for this one. And you can imagine that we're going to have, just for the first one, we're going to reject it and resolve it dependent. So then we can play. So after 1 minute, we want to do something like resolve with, and we're going to say just message. So success from promise one, perfect. Or we can reject it, reject. I'm going to say failure from promise one after 1 second. Then I'm going to copy entirely. You can imagine that we're going to have 2 and 3. As I told you, the only one, since it's the fastest, I'm going to make it the reject will be the first one. On the other 2, no, I will leave it because then I want to show you some of them. For example, the any, you have to reject them all to get the error and the response. So it's needed in all them. Promise 1, promise 2, promise 2, promise 2. This will be 2 seconds, 2 seconds, and promise 3, promise 3, promise 3, and of course 3 seconds. So now, in order to have them, you know that we need to wrap. In the latest version of Node, you can have the global async. So you can go ahead and start using await just at the root level. But I'm using the LTS, which is right now is 20.15. So we don't have that feature yet. So what we can do instead is use an if-I. If-I, if you don't know, comes from something like this. If-I. If someone in your interview, something you have it, it's just this concept. It's immediate or immediately, something like that. Immediately invoke function expression. Function expression. Immediately, it could be. Immediately invoke function expression. And what it is, you can have it async here. You have all the body of your application, of your closure there. And as soon as you close the first pair of parentheses, you invoke it immediately. It's like you do something like this. I'm pretty sure you have seen it in other examples. You put function init, function main, function boot, and you have function main, you declare everything you need, and then you invoke it, main. So it's exactly the same, but you have it in one line, and now we are making an async function and we have all the things we need. So with this in place, now I will be putting each case by case. So let's go side, flip back to the documentation. The first one is promise.all. So you can see fulfills is funny because you will see that some words go to one from to the other. So it's like a mouthful and they are all connected. Not connected, but you have, suppose you have any, and any could be here. So don't worry, it's going to be clear enough. So fulfills when all the promises fulfill, and reject when any of the three. If any promises reject, boom, is going to reject the entire mechanism, the entire process. Let me show you. So for the docs, don't worry, as usual, they're going to be leaving this code on the docs and also in the repo. So first.all. I'm going to make it like this. And now we're going to say const all, just to have the same name of the method we're using. We can make a call of await promise, as I told you, and you can invoke it. The good thing is they all have the same payload. They all expect an array of promises. So we can have promise 1, promise 2. You can see that I don't have copilot, so otherwise it will be quite simple. I'm a lazy guy there. So promise 1, promise 2, and promise 3. And then we're going to show what we get here. All plus the results of running it. So with that in place, we run promise.all, we send all the promises. Let me do this. First, we're going to fulfill them all. So all the ones that say reject, we're going to comment out. We're just leaving the happy path. Resolve, resolve, resolve. So we're going to resolve all that. As I told you, if you were doing this like in serialized or in series, you will have to wait 6 seconds because you have 1 plus 2 plus 3. But in all, with the promise.all, will be in parallel. So it's going to take as long as the longest promise. Since the promise 3 is the slowest and it takes 3 seconds, we're going to, after 3 seconds, get the response of all them. So going from 6 seconds to 3, which is half time, is really good. It's really good. Now we can go ahead, clean, remember Command K to clean the console, and you can do npm start, 1, 2, 3, and after 3 seconds, boom, we have the data. And please check this one because it's a huge difference. We get exactly the result, what the data result is wrapping. Just the message, the string itself. If I can put here instead of success the number 42, we're going to get 42 as the second value. So it's exactly what we send on the result. But now we're going to make any of them. Suppose we're going to make the first one just because it's the fastest, so it will be simple enough. If any of them is rejected, you will see this. Let me clean, run it back. After 1 second, boom, it explodes. But one function that people always complain about the old method is this. What can you tell about this one? You can see that it's failure for promise 1, but only that one. So you don't know about the other 2, if they were okay. Or suppose we don't do it on this one. Suppose we do it on something that is not the slowest. This is going to get through. So the first one is going to fulfill, but the second is going to be rejected. Now, let's see. Clean the console, npm start, 1, 2, after 2 seconds. Okay, it only gives you information. Of course, if you do the try catch and everything, you can go ahead and make it more neat treatment on this one. But we only get information about the crashing, the one that is exploding. We don't know what happened with the promise 1, with the promise 3. So people on the community always complain about that one. So this is a really good scenario when you know the source of the things you are consuming. So maybe you are writing backend, so you can take for granted that all the service is going to work. So promise.all is really good. If not, let me show you something. You have another method. So let's go back to the happy path. All them are going to, just in case, remember with Command C is shortcut. you're going to comment lines. With KU, command KU is you're going to uncomment lines. So command KC is to comment. Command KU to uncomment. So it's really, really productive. Now, since this crashed the entire application when something fails, we're going to comment the entire lines. And now we're going to use allSettled, settle with invoking. And it's going to be like this. allSettled, nice, thank you. It's going to be await promise dot allSettled, just in case, yeah, it's okay. allSettled is waiting for the same payload, which is from an array of promises, and then we will see what we're going to get there. Let's see, console instead of all will be allSettled, allSettled. Now let's see, because you will see in action. Boom, npm start is in parallel as well, so after 3 seconds, you can see it's providing more information. It's an array of objects, not just directly the string or the response that go inside the value. But you can see that it's giving you a status, fulfilled, fulfilled, fulfilled. So what is really good about this one is that suppose the first one is being rejected, it doesn't matter because you will always get the array of 3 objects. So that is really cool. So if you really depend heavily on all the calls to show the information, I think promise.all is really good because it's 100%, it's an atomic operation. Everything goes well or something goes wrong. With allSettled is when you can sneak something, okay? I don't need all the information, I can put something else. So if the quote doesn't come, I can leave the white space. So with this one, you will get it, even when it's rejected and fulfilled. If we check the docs, you can see promise.allSettled fulfill when all promises settle. Just there, period. Settle. Don't worry if it is fulfilled or rejected. It's going to give you the response. And here you can see, no matter if it's the fastest or the slowest, if you reject one and you resolve the others, you get the according results of that. So it's really, really good. I think the community is going beyond this one, prone to this one, because I think it's not the community. For me, it's depending on the scenario you are facing. It's really good. So as I told you, this one is not 100% of coverage or everything should go perfectly. So it's not the best scenario. So you can see, okay, I just need 2 out of 3 or 1 out of 3. Just I need something, or maybe everything goes wrong and you get all the rejected. But at least you will see this one was rejected, second was rejected. So you have more information about which specific promise because the results comes in the same order as the promise were fired up. So promise 1, promise 2, and 3, and you get in the same order the results, either success or failure. Then the next one in the chain is promise.any, fulfill with when any of the promises fulfilled. So it's like an optimistic kind of view because it's looking for any that fulfills. It's looking for some positive connotation there and reject when all them. So really any is a really optimistic thing. So it's going to look for any success and to make them crash, it really has to explode or reject all the promises. Let's go ahead and make it. It's going to be like this, going to be called any. And here, I love that you can be quite productive just using the same. And comment, and then this one is not good indentation, but for any, we're going to see, okay, let's see, we have 1 reject and 2 resolve. But let me show you this. Now, I think that example is perfect. What do you think is going to show? Since this one is being resolved and this one is being resolved. Since this one is faster than the third one, it's going to success from promise 2. Success from promise 2. Because this reject, okay, reject, don't worry. Let's check the second. Ah, success, good, and it was faster than the third one. But let me show you here, just to double check. I could be wrong there. And again, it's similar to all. It gives you exactly the string, so it gives you the value, not the object with the status and the value inside the value variable or property. No, just the value. Boom, it comes with the value. Just to make it fail, suppose this also failed, we can do and say, okay, let's go. Remember, it's looking for any that is goes well or fulfills. Now, if we do npm start, after 3 seconds, we get success from promise 3. To make it really crash or just reject, we need to reject all the promises, all the promises. Now, this would be similar to the same error we got on the, not the same, but at least it not crash at promise.all. It gives you an error with all the failures you have. So it's friendlier than the promise.all. I think that is what the community complains about, how abrupt the promise.all is, because crash the app if you don't handle properly. This one always gives you something. Could be the rejected, could be bad news or good news. But settle any, and you will see race in a moment, they behave differently. So here, all of them went wrong. So boom, we have the errors. You can see that it's like an object with the key error. So you have the errors as the key, and then an array of all the messages from the rejected. And finally, just to do the race, let me first read the docs to follow the same pattern. Promise.race settles when any of the promises settles. So it doesn't care if it is fulfilled or rejected. In other words, fulfills when any of the promises fulfills, or rejects when any of the promises rejects. So it's just looking for the first to settle. That is why it's a race. Of course, no matter what we're going to put here, if we use race for this one, let's go ahead and make this. First, we need to put the title for this guy. So it's going to be .any. And then similar to this one would be race. So it will be like this, race. Now we're going to call it as it is. And you will see, suppose since this is the fastest, let's see how it goes. Let's clean it, go ahead and npm start with race, and boom, but it crashes. So it's similar to, so we have two static methods which are more optimistic thing. We can say any are also and allSettled, they always give you something, no matter if it was success or failure, it will give you a response. But race and promise.all, in case that any failure we have, boom, it crashed the app. So they have like two siblings, the good and the bad brothers and sisters here. Now, suppose this one, and this is the one I want to show you. Suppose that the second is going to fulfill after 2 seconds. To raise, this doesn't matter, because the first one, which was faster than the second, rejects before. So it's taking just care of which one is the fastest on doing something, on being settled. So now if we want to make at least this one, suppose now the first one would be a positive connotation, we're going to be resolved. What do you think is going to show? Of course, this one, because it's faster than the second one. That is one is a race, it's like a car race. npm start and just the promise. Again, similar to promise.all. You get exactly just the information. So here, there you are. So when you use it, suppose if you only care about you are consuming a third party that you don't write, so something that is a public API, maybe you're making several calls, you would like to make a race because you want something fast to show on the screen. And if it is an error, handle properly, and if it is some information, show it on the screen right away. So that would be a good scenario to use raise. That you can have everything wrong. If you want to really handle and show exactly more information, I think any is more optimistic. I think the word optimistic is really good because you're never going to crash the app. It's going to give you either success or fail, a response. The same go to allSettled. So it's up to you when to use either of them. But I hope that all the things, all these examples were clear enough for you. And then, as usual, I'm going to be putting this on the repo. I will be pushing, and in the description, I will be giving you the link to the repository. If you like the video, please click on the. Sorry, it was really long, but with this one, you will be making a really good improvements in your application. How you memory consumption, how you make different goals in parallel. So it could be really, really cool how you can improve and make your site better with this concurrency about promises. So if you like the video, hit on the like button, please. If you really like, subscribe because I will be publishing more new material about this one, JavaScript, and some more technologies that I like, such as Next.js, React Native, React itself, Solidity, and smart contracts. So keep tuned and have a great day. Take care.